Welcome to Sri Lakshminarayana Matriculation Higher Secondary School. We are from Science branch. Now we are going to be discuss about Physics practical from 10th standard. We have three different practicals in 10th standard. Over there, first one is a determination of weight of an object by using principle of moment. Second, determination of focal length of a convex lens. Third, resistivity of a material using Ohm's law. So three different experiments we have in 10th standard. Now we are going to discuss about second experiment, determination of focal length of a given convex lens. If you are going to be discuss about the experiment, first of all we know about what is meant by lens, how they are classified, some informations we need to collect, then only we can do these experiments properly. So first of all, we know what is meant by lens. A lens is nothing, it's a transparent medium. It's a transparent medium. An amount of light rays travel from one medium to other medium. Medium is nothing, it is used to transfer, it is used to send information from one place to other place. Now we are using a transparent medium like a glass. So this glass is made up of this glass is spherical in shape. Two spherical shapes are bound together form a lens. The center of a lens is thicker, is called as a convex lens. So this is commonly called as a convex lens. And another one lens we have, so that is also a transparent medium, transparent material. At the same time, it is a spherically bounded. The center of a lens is very thin. It's called as a concave lens. We have two different types of lens. So from this experiment, we are going to discuss about convex lens focal length. Convex lens focal length. So how the light rays are converging, how the light rays are diverging by using the given lenses. Now we are going to be discussed one by one. So this figure represents convex lens and second figure represents concave lens. From convex lens, an amount of this yellow lines or represents a number of light rays or incidents on the surface of a convex lens. So after incident, all the light rays converge at one point is called as a focus point. Is called as a focus point. So this point is used to collect the image. Now we are going to be calculating focal length of a convex lens. The distance, what is meant by convex lens is nothing. We know the definitions about convex lens, and what is meant by focal length. Focal length is nothing, is the distance between focus point and center of a lens. Center of a convex lens is called as a focal length. So from this lens we are collecting a real image. Real image is nothing, it's an inverted image. Okay, so the inverted images are commonly called as a real image. So by using convex lens, all the light rays are converge at one point. So is commonly called as the convex lens are commonly called as a converging lens. At the same time, we are collecting a real image. So real image is nothing. We are collecting a inverted image of an object. Inverted image of an object. So concave lens. From this concave lens, same the number of yellow lines are represents light rays. All the light rays are incidents on the surface of concave lens. After incident, a number of light rays are diverging in different directions. So these dotted lines represent imaginary lines. So from concave lens, we are collecting a image in front of the lens. In front of the lens, so those images are called as virtual image. There is no changes of an image. Okay, it's called as a virtual image. So these are all the informations we know. We can easily do this experiment like a determination of focal length of a convex lens. So we have two different method is used to find the focal length of a given convex lens. So what they are? One is distant object method, another one is UV method. Distance object method, second one is UV method. First we are doing distance object method is an easiest way to measuring the focal length of a given convex lens. Before going to discuss about the method, we know what are the apparatus we need for doing these experiments. Let's see. So we need one convex lens. The center of a lens is very thick in nature. It's called as a convex lens. Lens stand, screen and wire gauze. So it acts as an object. It will be act as an object. Now we need a meter scale is used to measuring the distance by using this meter scale. So these are all the apparatus we need to do this experiment, determination of focal length of a convex lens. So first method is UV method. From this method, how we do this experiment? Distance object method. Now we keep a lens on the lens stand. When the screen is placed behind the lens, now we focus an object is placed in front of the lens. Now we adjust the distance between the lens and screen. So we collect a real image. The object of an image is inverted in nature. So we collect a real image. So now measure the distance between lens and screen is 10 centimeter. The distance between the lens and screen is 10 centimeter. So this distance are commonly called as a focal length of a given convex lens. So now we write the focal length of a given convex lens. So 10 centimeter. So now we collect the data from a distance object method. Now we write the data for f is equal to 10. So f is equal to 10 is nothing. A focal length of a given convex lens by using a distance object method. F is equal to 10 centimeter. So now this data is converted into 2f. So 2f is nothing. The given data are multiplied by 2. So the answer is 20 centimeter. 20 centimeter is the value of 2f. 2f is equal to 20 centimeter. Very good. So this is a UV method. Next, this is distance object method for calculating focal length of a given convex lens. F is equal to 10 centimeter. Next, we are going to discuss about UV method. From this method, we have three different conditions. We can easily find the focal length of a given convex lens. So what they are? One is U is greater than 2f. Second condition, U is equal to 2f. U is less than 2f. Here we know the value of U. What is meant by U? U is nothing. It is the distance between. It is the distance between object and the lens. So U is nothing. The distance between object and lens. From this condition, we collect a diminished image of an object. Okay. So next condition, U is equal to 2f. U is equal to 2f means we are collecting a same size of an image. There is no changes of a size of an image and object size. So next we are going to discuss about third condition. U is less than 2f. U is less than 2f. From this we are collecting a magnified image. The image size is greater than object size. So these three conditions we are going to be discussed by UV method. Before going to discuss, we write the data about the distance between object and lens. Okay. So first we know U is equal to 2f. U is equal to 2f is nothing. 2f is we already collected the data values of 2f is equal to 20 centimeter. Write 2f value here. U is equal to 2f is equal to 20 centimeter. So U is greater than 2f. We know the value of u is greater than 2f. We know the value of 2f. 2f is 20. So the greater than 2f values are, we can easily know. So we write some data. Those data are easiest way to calculating the focal length of a given convex lens. Now I write the data are 22 and 24. These two data are greater than 20. Next, third condition is u is less than 2f. From this condition, we know the 2f value is greater than u, or u value is lesser than 2f. U values are lesser than 2f. Now we reduce the data 20 centimeter. So now we write data are 18 and 16. These two data are lesser than 20 centimeter. So we know the distance between object and lens. Now fix the distance. We can easily calculate v value. So v is nothing, the distance between the lens and screen. Now we are going to do the experiments. After complete the experiments, we collect the data and tabulate the tabular column. From UV method, we know what is U and what is V. We already discussed, but I explained by using the given apparatus. So a lens is placed between the object and screen. The distance between the lens and object is U. U is nothing, the distance between object and lens. We keep a lens between the object and screen. The distance between lens and object is u. Small u represents distance between lens and object, and v represents the distance between lens and screen. Small v represents the distance between lens and screen. So from this method, these two factors are very important for calculating focal length of a given convex lens. Okay, yes. So we have three different conditions. First conditions we are going to be do u is greater than 2f. From this conditions we are going to be collect a diminished image of an object. The distance between lens and object is 24 centimeter. Now fix the distance between the lens and object. centimeter. Now we take the reading from the center of a lens and the point of a light source. The point of a light source. So this is the point of a light source. So this point of a light source are commonly act as an object. So we measure the distance between lens and object is 24 centimeter. So this is a fixed value. Now we find the v value by adjusting the screen distance, or distance between lens and screen. We collect the data for v. From the adjustment, we collect image size is very diminished or very smaller in size of an object. Image size is very smaller compared to object. Now after fixing the distance between object and lens, now we adjust the distance between screen and lens. We collect a clear image of an object. So the image size is very smaller compared to object size. Okay, so this value is represents V. So V is nothing, distance between lens and screen. Now we measure the distance between lens and screen. The data is 18. So 18 is nothing, is the distance between lens and screen. So the value of V is 18 centimeter, right? Now we write the value of V, the given tabular column, 18 centimeter. Simultaneously we adjust the distance between lens and screen, and distance between lens and object by 22 centimeter. From this data we know the V value. Similarly, we adjust the distance between object and lens. We collect the value of V. The values are 18.18, first 24 U value, and V is 18. 22 U value, V value is 19.5, and the second condition U is equal to 2F. The value of U is 20 centimeter and the value of V is 20.5 centimeter. Third condition, from third condition U is less than 2F. We have two data for U. So from 18 V value is 24.0 or 24, right? 24. Next, the value of U is, the value of U is 16 centimeter and the value of V is 27.5. After we collect the data, all the data are substitute the given formula. F is equal to UV divided by U plus V. So small f represents focal length of a given convex lens. U we know data and V also we know. Substitute known data from the given formula. U is equal to 24 centimeter and V is equal to 18 centimeter. From the formula F is equal to U value 24 into V value 18 divided by U plus V. U value 24 plus V value 18. After calculation, we know known values of F is 20.18, 20.28. Sorry. Now we substitute known data for given formula. F is equal to 24 into 18 divided by 24 plus 18. By calculation method, 24 into 18 we know data 432. 24 plus 18 we know 42. After divide the given data, we collect the data of 10.28. 10.28 is the focal length of a given convex lens. So write this data, the given tabular column 10.28. Same procedure we need to follow by calculation method. Writing the given data. The data are 10.33, trial number 2, 10.12, 10.28 and 10.1. So all the data are from separate calculations of a focal length of a given convex lens. We know we need to calculate the mean value of a given data. You people will know how to calculate a mean value. So by adding all the values, so how many trials we done? There are 5 trials. So divide the given data, sum of the data divided by number of trials. So number of trials is 5. So after adding divided by 5, the value of F is equal to 10.1. 10.1 centimeter is the focal length of a given convex lens using a UV method. From UV method, the data are 10.1 is the focal length of a given convex lens by using UV method. Now we write the data of a focal length of a given convex lens are given in your result. Okay. So from the result we know we have 2 methods. From distance object method, we already calculated F value. F values are given. We already written here F is equal to 10 centimeter. So this data are we collected from distance object method. Now we write here 10 centimeter is distance object method of a focal length of a given convex lens. Next UV method. From UV method we know after calculations we collected mean value of a given data. So 10.1 is the focal length of a given convex lens by using UV method 10.1. From this method there are, if we compare these 2 methods, the data from distance object method and UV method, there is no much more difference between the 2 data. So from distance object method 10 centimeter, UV method 10.1 centimeter, there is no much more difference between the 2 data. We consider number 10. So 10 is the focal length of a given convex lens. So these 2 from the result we conclude if we have 2 different methods, we are collecting 2 different data, but there is no much more difference between the 2 data by using the 2 method. We have a number of convex lens, so each lens having a separate focal length, respective focal length. We can be calculate the focal length of a convex lens by using these 2 methods. There is no difference, there is no much more difference between the given data. Thank you. Here F is equal to 10.1 centimeter is nothing. We are collecting data of a focal length of a given convex lens by using UV method. So this data is nothing, it's a focal length of a given convex lens. So what convex lens we are using in this experiment? So the focal length of the given convex lens is 10 centimeter, 10.1 centimeter. So 0.1 is nothing, it's a fractional error, so we won't mind. So we consider only 10. So 10 is a focal length of a given convex lens. We have a number of convex lens. So each convex lens are having a different focal length. We can measuring the focal length of a given convex lens by using 2 different methods. Thank you.